Hello everyone, my name is Kevin McCabe with the National Renewable Energy Laboratory. Welcome to today's webinar hosted by the Carbon Capture, Utilization, and Storage, or CCUS initiative, an initiative of the Clean Energy Ministerial. Today's event is brought to you by representatives from the Japan CCS Company and the Ministry of Economy, Trade, and Industry, and is titled Carbon Capture, Utilization, and Storage in Japan. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or over your telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. This option is preferred as it will eliminate the possibility of feedback and echo. If you choose to dial in by phone, please select the telephone option and a box on the right-hand side will display the telephone number and audio pin you should use to dial in with. If anyone is having technical difficulties with the webinar, you may contact the GoToWebinars help desk at the number shown on the screen. If you'd like to ask a question, we ask that you use the questions pane, where you may type it in at any time during the webinar. Shortly following the conclusion of the event, the recording will be added to YouTube and the presentation slides will be uploaded to the Clean Energy Solutions Center site, links for which can be found on this slide. Before we launch into the presentations, I will provide a quick introduction of today's panelists, followed by a welcome from Brian Allison of the SEM CCUS initiative and the UK government, who will provide context for today's webinar. Then, following the panelists' presentations, we will have a question and answer session where the panelists will address questions submitted by the audience. Our first speaker today will be Brian Allison with the Department for Business, Energy, and Industrial Strategy, and also co-lead of the SEM CCUS initiative. Following Brian will be Yoshihiro Sawada, Corporate Advisor and General Manager within the International Affairs Department of Japan CCS. Next up will be Jiro Tanaka, Associate General Manager within the International Affairs Department of Japan CCS. And finally, we will hear from Yukihiro Kawaguchi, Director of the Global Environmental Affairs Office within the Ministry of Economy, Trade, and Industry. And with those brief introductions, I would now like to welcome Brian to the webinar. Brian?
Thank you, Kevin. Ladies and gentlemen, as Kevin has said, my name's Brian Allison. I'm one of the 4 co-leads of the Clean Energy Ministerial CCUS initiative. It is my pleasure to welcome you on behalf of the initiative and its members. Thank you for joining us from across the world. Some of you early in the morning, some late at night. We are very much appreciative of your time. I would also like to thank our good colleagues and friends from Japan, both at METI and Japan CCS, for today's webinar presentations. Before handing over to our speakers, I would like to briefly introduce the Clean Energy Ministerial CCUS initiative to those of you who have not heard of us before. Next slide. The Clean Energy Ministerial, or the SEM, has been in place since 2010 and today has 26 full members across the world from all continents and both North and South. The SEM member countries make 90% of clean energy investment globally, but they also are responsible for 75% of global CO2 emissions. So this is a very good global partnership. Next slide. The CCUS initiative is one of over 20 work streams under SEM. Our members are 12 SEM governments. And if you look at our membership, you will notice that it represents the critical mass of countries who lead on CCUS globally. Our initiative is led by 4 countries: Norway, Saudi Arabia, the US, and the UK. Next slide. Our common objective, as portrayed in our logo, is to accelerate carbon capture together. We do this because we believe that CCUS has a vital role to play as a part of clean energy portfolio. And because now is the time to accelerate, we accelerate CCUS together. Firstly, by actively working to include CCUS within the global clean energy agenda. Secondly, by bringing together the private sector, governments, and investment community. Thirdly, by facilitating identification of both near and long-term investment opportunities. And finally, by disseminating best practice in CCUS policy, regulation, and investment through webinars such as the one today. Next slide. Please follow our work via the various social media platforms and get in touch by email if you want to know more about our work. You will have access to these slides. There'll also be a video to collect of the Tomakomai demonstration plant as an added incentive to pick up the slides, and the links will be there for the webinar. It is my very great pleasure to now pass the floor to Mr. Yukihiro Sodawa and Mr. Jiro Tanaka from Japan CCS for a presentation on the Tomakomai CCS Demonstration Project. This will be followed by a presentation on Japan's CCUS strategy by Mr. Yukihiro Kawajushi from METI. Over to you.
CCS technology is already being used around the world. In Japan, the Ministry of Economy, Trade and Industry, or METI, launched a demonstration project in 2012 in Tomakomai, Hokkaido. The project in this port city is shedding light on the new possibilities for CCS. This project aims for the practical use of CCS technology by 2020 and is being carried out over 9 years in the western part of the Tomakomai port. The 4-year span from 2012 was allotted as the preparation period. During this time, the construction and installation of the facilities were carried out. In April 2016, the injection of carbon dioxide began. This is a gas supply facility in the Idemitsu Kosan oil refinery, which is adjacent to the Tomakomai demonstration plant. Gas containing carbon dioxide is sent from this facility by a pipeline to the Tomakomai demonstration plant facilities. The 48-meter-high CO2 absorption tower uses a chemical solvent, amine, to absorb the carbon dioxide. In the Tomakomai demonstration project, a 2-stage CO2 absorption process has been applied. The 3 towers comprise the main equipment in this advanced process. The captured carbon dioxide is now sent to the compression facility. Here, the CO2 is compressed and injected into deep offshore sub-seabed reservoirs. This building houses the heads of the injection wells, which extend far below the seabed. For this demonstration project, 2 injection wells were drilled. One reaches a formation between the depths of 1,000 to 1,200 meters and is called the Moebetsu Formation. The other extends into a formation between 2,400 to 2,800 meters. It's called the Takinoue Formation. The pores of the rocks forming the reservoirs are filled with saline formation water. The injected carbon dioxide pushes the water out and enters these pores. An underground monitoring system is essential for conducting the demonstration project safely. Temperature and pressure sensors have been set in the injection wells, and in addition to these sensors, seismometers have been set in the observation wells. There are 3 observation wells. In addition, ocean bottom seismometers and other devices are continuously monitoring the sub-seabed conditions. In the northern lands of Japan, a large-scale demonstration project is being conducted with the aim of verifying the practical use of CCS technology in Japan.
Thank you, Brian, for your kind introduction. We would also like to thank the Clean Energy Ministry for hosting this webinar. Today, we will share some of our experiences from the Tomakomai CCS Demonstration Project. Now for our presentation. Next slide. Next slide, please. To provide some background for this presentation, the Tomakomai CCS Demonstration Project began injection of CO2 in April 2016. Reaching the target of 300,000 tons November last year. Early this year, METI, NEDO, and Japan CCS held expert review meetings to discuss and summarize the issues of the project. The results were compiled into the summary report, which will be a main topic of our talk today. Next, please. Our presentation will be in 2 parts. I will present part 1, an overview of the Tomakomai project, followed by the key result. Part 2, public engagement and issues, and summary, will be presented by Jiro. Next, please. I will start right away with part 1. Next, please. These are the photos of Tomakomai City, the demonstration facilities, and the sea under which CO2 is being stored. Next, please. The Tomakomai project is the first large-scale CCS demonstration project in Japan. Tomakomai is a large city located on Hokkaido Island, 800 kilometers north of Tokyo. The project was commissioned by METI, NEDO, and contracted to Japan CCS. Next, please. To recap the project schedule, it took 4 years for surveys and site selection, and 4 years for construction. CO2 was injected for 3 years and 8 months. Last November, we achieved the target of 300,000 tons. Monitoring work is being continued. Next, please. This is a project scheme. The CO2 emission source is a hydrogen production unit of an oil refinery. The CO2 capture facility has a capacity of 200,000 tons per year. After CO2 capture and compression, the CO2 is injected into 2 offshore subsurface formations. Next, please. This is a bird's eye view of the Tomakomai capture and injection facilities. The yellow arrow shows the flow of CO2-rich gas from the refinery. The gas is sent to the absorption tower where the CO2 is captured. The captured CO2 is compressed and sent to the injection wells along the red arrows. Next, please. This is a schematic diagram showing how we utilize directional drilling technologies to drill 3 to 4 kilometers from onshore to offshore to access 2 different reservoirs, the Moebius Formation, a sandstone layer, and the Takinoue Formation, a volcanic rocks layer. By drilling from onshore and drilling under the harbor, we saved drilling, operation, and maintenance costs and avoided disturbing the marine environment and the harbor operations. Next, please. Okay. As we showed in the the slide shows an extensive monitoring system comprised of observation wells, ocean bottom seismometers, and the ocean bottom cable. Inside the red box, we are monitoring microseismicity, small tremors. The orange dotted line is a working area for 3D seismic surveys in order to monitor the behavior of CO2. Next, please. This is a schematic diagram showing the various sensors installed in the monitoring system. The injection wells in red are equipped with pressure and temperature sensors. The observation wells in green are equipped with pressure, temperature, and seismic sensors. The ocean bottom cable is equipped with 72 seismic sensors. Next, please. The Tomakomai CO2 capture process is a 2-stage absorption system comprised of a CO2 absorption tower, CO2 stripping tower, and a low-pressure flush tower. CO2-rich amine is sent to the low-pressure flush tower, where much of the CO2 is stripped by flushing, which does not consume energy. Only a small amount of semi amine needs to be sent to the CO2 stripping tower, resulting in a very small reboiler duty. Next, please. Next, for the key result of the project. Next, please. This slide shows the operational result. We achieved the designated capture amount, recovery rate, and capture energy. Also, complete automation of the CO2 compressor control system, as well as simultaneous injection into 2 different reservoir types. We adopted a 2-stage absorption process, employing activated amine, achieving the capture energy target of less than 1.22 gigajoule per ton CO2. As explained previously, much of the CO2 is stripped by flushing, and only a small amount of emitting amine is sent to the CO2 stripping tower, resulting in a very small revoided duty of about 0.9 gigajoule per ton CO2. The gross capture energy, including the boiler efficiency and the pump electricity, was about 1.2 gigajoule per ton CO2. The energy efficiency achieved by this system is world-class, much lower than a conventional system. Next, please. This slide shows the injection result. Of the 300,000 and 110 tons cumulative CO2 injection, almost all of the injection was into the Moebius formation, a sandstone layer with very good injectivity. On the other hand, the injectivity of the Tomakomai formation, a volcanic rocks layer, was very poor, and only 98 tons was injected. The graph shows the injection record of the Moebius formation. The blue curve is the bottom hole pressure. The maximum bottom pressures recorded during the injection were much lower than the upper limit set to avoid damage to the overlying cap rock, including that the injection went very smoothly, indicating that the injection went very smoothly. Next, please. This slide shows the result of microseismicity monitoring. Prior to setup of injection, 9 events were detected, and after startup, 3 events were recorded. All events are much deeper than the injection area, and are very small microseismic events which can occur in this domain. No microseismicity or natural earthquakes attributable to CO2 injection were detected in the vicinity of the injection area, confirming that no earthquakes have been induced by CCS. Having baseline data prior to injection was important. Next, please. Seismic technology developed by the oil and gas industry is widely used in CCS to monitor the behavior of CO2 in the subsurface. Seismic surveys are repeated at different stages of CO2 injection. We have conducted 3D seismic surveys prior to CO2 injection at 60,000 tons and at 200,000 tons of CO2 injection. The bright spots correspond to the extent of the injected CO2 and confirm that the CO2 is stably stored in a limited area and injection well, and that the CO2 plume is evolving with the progress of injection. Next, please. This slide shows the result of marine environmental surveys. We are required to conduct quarterly marine environmental surveys in accordance with domestic law governing offshore CO2 storage administered by Ministry of Environment. A cross plot of dissolved oxygen saturation and the partial pressure of CO2 in the seawater is created, and the threshold line is used to detect for possible CO2 leakage. The former threshold line was derived from a baseline survey conducted from fiscal year 2013 summer to fiscal year 2014 spring prior to injection. In the fiscal year 2016 and fiscal year 2017 surveys, some data exceeded this threshold, and injection was suspended for 6 months. Based on results, including confirmation surveys, the Ministry of Environment expressed the view that CO2 leakage has not been confirmed. We believe the former threshold curve being derived from only 1 year's data was insufficient in reflecting natural variation in seawater CO2 concentrations. The threshold was revised in summer of fiscal year 2018, including more data. Thereafter, no data exceeding threshold has been observed. Next, please. This slide describes the laws that were applied to conduct the project. As Japan has no CCS-specific laws excluding offshore CO2 storage, existing laws and regulations were applied to govern the operation of the project facilities. As shown in the figure, a combination of 6 laws were applied. Next, please. This slide shows some of the issues that have become apparent. Regarding the marine environmental surveys, the index currently used to detect possible CO2 leakage could generate false positives caused by natural variations rather than actual leakage. With regard to CO2 storage, provisions for long-term reliability and the transfer of such reliability have yet to be established in Japan. There is only mention in the Act on Prevention of Marine Pollution and Maritime Disaster that as long as there is storage of CO2 in the subsurface, the implementer must continue monitoring. There still remain issues in the legal and regulatory framework for CCS in Japan. Next, please. This slide explains a cost estimation that was conducted as the Tomakomai project was a demonstration project with extra facilities. A commercial model which excluded these extras was considered. We considered 2 cases, a 200,000 tons per year model, which was the scale of Tomakomai demonstration project, and scaled up 1 million tons per year model. The cost estimate was based on Tomakomai demonstration data under similar conditions and certain assumptions such as 25 years depreciation. For the 1 million tons per year model, the estimated cost per ton CO2 captured is about $57, and the cost per ton CO2 avoided is about $67. This concludes part 1. Next, Jiro will present part 2. Jiro, the floor is yours.
Okay, thank you, Yoshiro. Okay, now for part 2. Next slide, please. Okay, because the Tomakomai project is being carried out not far from the center of Tomakomai City, which has a population of 171,000, extensive public outreach activities are being carried out. Next, please. Okay. So before starting the project, we conducted a survey of local citizens who asked for thorough information disclosure, expressed concerns about safety, and the need for involving the young generation. This was reflected in our public outreach activities such as panel exhibitions, forums for Tomakomai citizens, and site tours. We set up an information disclosure system so that the local community could follow the day-to-day activities. As a result of these activities, we have maintained a good relationship with the local community. Outside of Tomakomai, Japan CCS conducts public outreach activities in widespread areas in Japan, participating in activities such as environmental exhibitions and giving lectures at universities. Next, please. Okay. So yes, these are some issues that have become apparent. Public awareness of CCS is still very low. If you go outside of Tomakomai, hardly anyone has heard of CCS. So we should continue our knowledge enhancement activities. Japan CCS is also approaching new areas outside of Tomakomai as part of another important activity we are engaged in, the investigation of potential CO2 storage sites offshore Japan. We've found it is important to have the local community know that the government is responsibly advancing the project and to implement activities that suit the region. The key objective is to build a trusting relationship with the local community. Next slide, please. The Tomakomai CCS Demonstration Project is a rare project in the world where the government, private sector, and local community have joined efforts to achieve results. We are actively showing the project to the international community. Over 1,400 people from overseas have visited the site. We are also sharing the results and learnings of the project in international conferences. As a future step, we are looking for opportunities for collaboration with international organizations with a view to overcome common issues and barriers to CCS. Our view of the present situation is that discussions regarding legal and regulatory frameworks for CCS and the design of business models are more advanced overseas. Therefore, it is important, as well as an effective approach, that we actively participate in this international discussion. Next slide, please. The next few slides highlight a special concern for CCS in Japan: earthquakes. The safety and security of CO2 storage at the Tomakomai site was seriously tested by a major earthquake in September 2018. The magnitude was 6.7, which is quite large even in Japan. The epicenter was 30 kilometers from the injection area at a depth of 37 kilometers and caused massive destruction in a nearby village. The seismic intensity at the demonstration site was lower 5, but no damage was incurred by the facilities. Next, please. This diagram shows what was happening in the Moebetsu Formation injection well before and after the earthquake. We had been injecting from July, as indicated by the rise in the bottom hole temperature and pressure. 5 days prior to the earthquake, the supply of CO2 from the refinery stopped due to technical issues, causing a suspension of injection, and the temperature and pressure in the well were in decline. It was during this decline that the earthquake struck. It caused an island-wide blackout, causing a break in the data as we lost power. However, when we regained power 3 days later, the continuation of the decline can be observed. This is a clear indication that the conditions in the reservoir were not affected by the earthquake. Japan CCS convened an expert review meeting comprising top scholars in seismology 1 month after the earthquake. A comprehensive review was conducted, and the unanimous conclusion was that no leakage of CO2 had been caused by the earthquake, and that there is no data suggesting a connection between the CO2 injection and the earthquake. As part of this discussion, the stress change that could be caused by the CO2 injection at the hypocenter of the earthquake was calculated. It was found to be about 1/1000th of the pressure change exerted on the earth crust by tidal forces, and was therefore negligible. A detailed report of this meeting was posted on our website. Next, please. This slide summarizes the actions we took after the earthquake. The diagram you saw on the previous slide was posted on our website just 6 days after the earthquake, as soon as we could get the data together. An expert review meeting was convened a month after the earthquake, and a detailed report was posted on our website. Now, major earthquakes are typically not one-time occurrences, but are followed by numerous aftershocks. The largest aftershock of this earthquake to date occurred on February 21, 2019, recording a magnitude of 5.8. Once again, we posted our data on our website 5 days later, explaining that there was no indication of CO2 leakage. Actually, just after this February aftershock, a very prominent political figure tweeted, blaming both the initial tremor and the aftershock on the CO2 injection. This caused a flurry of activity on social media. However, the authorities were also quick to respond, classifying the tweet as false news and warned not to be misled. The social media activity subsided after a few days. So in our response to the earthquakes, we have made an effort to respond as quickly as possible and to include technical data with our explanation. We believe this is very important, as otherwise there is a risk that the project may become tainted with false news or information. So next slide, please. And the next, please. Now, to summarize the presentation, with regard to the key results of the project, we have successfully operated a full chain CCS system, demonstrating its safety and reliability. The capture system achieved world-class performance in energy efficiency. The onshore to offshore injection scheme saved drilling costs and avoided disturbing the local livelihood. We have addressed concerns about earthquakes, and our public outreach program has been largely successful with no major opposition to the project. However, we still have a lot of work to do. We need to establish a comprehensive legal and regulatory framework for CCS deployment. We must also enhance public awareness of CCS. Next, please. This concludes the Japan CCS presentation. Thank you very much for your attention. The next presenter is Mr. Yukihiro Kawaguchi of the Ministry of Economy, Trade, and Industry of Japan. Mr. Kawaguchi, the floor is yours.
Hi, everyone. Good morning and good afternoon. My name is Yukihiro Kawaguchi, Director, Global Environmental Affairs Office of the Ministry of Economy, Trade, Industry in Japan. And now, as the CCUS has introduced, Japan has reached a significant milestone with an accomplishment of injecting 300,000 tons of CO2 by Tomakomai CCS Demonstration Project. So by taking this chance, I introduce the current status of CCUS policy in Japan. So next slide, please. Okay, first, I introduce Japan's long-term strategy under the Paris Agreement. And the basic concept of long-term strategy has 3 points. One is to accomplish decarbonized society as early as possible in the second half of this century, and also take measures towards the reduction of greenhouse gas emission by 80% by 2050, and to realize a virtuous cycle of environment and growth. And within this long-term strategy, it specifies CCUS as one of the key technologies for accomplishing decarbonized society. Next slide, please. And this slide shows the implication of 80% reduction for Japan, which is a long-term goal of our long-term strategy. So if we set the base year 2013, we need to realize around 250 million tons of CO2 emission in 2050, which is shown in gray area in the right-hand side. And even if we achieve zero emission from energy conversion, which is blue in the bottom part of the center, and transportation sector, which is also blue in the upper part in the center, there are 360 million tons of CO2 emission from industrial processes, which is shown in the left-hand side. And this number is still bigger than the 250 million tons of CO2 in 2050. So it shows that we believe the innovative technology, including CCUS, is indispensable for our long-term goal of our decarbonization. Next slide. And there are two milestones for CCS in Japan. First one is specified in our strategic energy plan. And it says that research and development will be conducted with a view to practical use of the CCUS technology around 2020. So as we have introduced, achievement of 300,000 tons of cumulative CO2 injection of Tomakomai CCS Demonstration Project proved CCS is a safe and secure system in Japan. And second milestone, introduction of CCS by 2030 and the coal-fired power generation will be considered with a view to commercialization. This is specified in the long-term strategy under the Paris Agreement. Next slide, please. So now our goal is kind of the milestone is 2030. So actually this year we have conducted a study for introduction of CCS, and we have organized study group. And this study group has a participation from industries, and as a result, electric power, steel, and chemical industries acknowledge CCS as indispensable technology for their decarbonization. And also, we have conducted integrated model analysis to analyze how we can achieve 80% reduction and how much it is. And that analysis says 3 points. One is that the availability of CCS will help to reduce the cost of emission reduction after 2030 and under any scenarios. Second point, in the case of 80% greenhouse gas emission reduction in Japan, no feasible solution could be obtained in the case where CCS is not utilized. And third point, CO2 storage in 2050 is estimated to be about 92 million tons CO2 per year in the standard case and 182 million tons CO2 ton per year in the expansion case. And next slide. And also in the study group, we have analyzed the business model, and this is simple business model. In Japan, there are already facilities that separate high concentration of CO2, such as natural gas production facilities and ammonia production facilities, although on a limited scale. So in the initial stage, this could be the case as shown in the figure upward. And large-scale CCS projects are needed to implement CCS at a scale of 100 million tons by 2050. So in this growth stage, we need to use pipeline as well as liquefied CO2. Next slide, please. This slide shows a time frame image between 2020 and 2050. And there are 2 points in this slide. First, the time frame before the year of 2030, because 2030 is our next milestone. And we understand it takes more than 4 years for site evaluation and feasibility study, plus around 4 years for constructing the CCUS facilities and plants. That means we need more than 8 years before introducing CCS. Thus, if we are to introduce CCUS on the premise of commercialization from 2030, we need to enhance business environment by 2027 at the latest to make the final investment decision of the project. And the enhancing business environment means, you can see upwards, for example, cost reduction, incentive, and as Zero has introduced, we need legal frameworks such as long-term liability issues. And also we need to conduct site survey for large-scale storage. And of course, public acceptance is the key. And second, the time frame between 2030 and 2050. And in the study group, we agreed that rather than linear introduction of CCS from 2030 to 2050, gradual expansion while reducing cost is more acceptable. This is shown in the image of this slide. Next slide, please. And this slide shows what we will do at Tomakomai CCS Demonstration Project. So we have achieved the initial target of approximately 300,000 tons cumulative injection in November 2019. So now we are planning to use CO2 and H2 to make chemical such as methanol. Then we can realize a hybrid system of CCS and carbon recycling, we call, in Tomakomai. You can see the image of CCS and carbon recycling in the right-hand side picture. And next slide, please. And this slide shows CCS demonstration project in Japan. And in Japan, actually, potential large-scale CO2 storage sites exist along the western coast, which is upper side in this picture. And while most of the large-scale CO2 sources from power plants exist along the eastern coast, downsides of this picture. Thus, we need CO2 transport ship to connect CO2 sources and CO2 storage sites in the future. That's why we have started the study of CO2 transport ship this year. And currently, we have 3 plans of carbon capture demonstration project other than Tomakomai. First one is IGCC with CO2 capture and carbon recycling facility, and also biomass power plant with CO2 capture. The capture will start from 2020 this year. And also we have a demonstration project of coal-fired plant with solid solvent for CO2 capture, and the capture will start 2023. And of course, we have the Tomakomai CCS with carbon recycling. And in Tomakomai, of course, we have already injection well. So by connecting these CO2 sources of demonstration projects with Tomakomai storage site by CO2 transport, it is possible to make hub and cluster model before 2030. Of course, this is still a plan, but it can be possible. And next slide. And this slide shows our worldwide cooperation for CCUS development and deployment, because we firmly believe that bilateral and multilateral cooperation is a key for the introduction of CCUS, both within Japan and globally. So, for example, with the EU, we have a joint press statement at G20 Caloriza, including CCUS. With the UK, there's a MOC between METI and BASE, and we have organized METI-BASE CCUS workshop. There's a picture of Mr. Brian Anderson in this picture. And also with Saudi Arabia, we have now conducting feasibility study for CO2-free ammonia supply with CCUS. And with Indonesia, we have started feasibility study for applying CCUS to joint crediting mechanism under Article 6 of Paris Agreement. And with Canada, there is a MOC between JCCS and International CCS Knowledge Center. And with the USA, we have a MOC, and under this MOC, we have the research cooperation on microbubble and optical fibers at North Dakota. And of course, Japanese companies are participating in Petronova CO2 project. With Australia, there is a hydrogen energy supply chain project with CCUS. So again, this kind of the cooperation is really the key. So we keep up cooperation and communication, and we want to work together for the development of CCUS. Thank you very much. This is it.
Great. Thank you to each of the panelists for those outstanding presentations. As we shift to the Q&A, I would like to once again remind our attendees to please submit questions using the question pane at any time. While I wait for some more to roll in, we do have a couple great questions already asked. The first one is for our JCCS colleagues. Why was Tomakomai selected as the CCS demonstration project site?
Thank you very much. Very nice, good question. At first, we had 115 candidate places. After an evaluation of existing data and site surveys, Tomakomai was finally selected because, firstly, the Tomakomai site had a very good reservoir. Secondly, Tomakomai had a good cap rock. And thirdly, no active faults were found at the Tomakomai site. Fourthly, the local community, especially the city mayor, supported the CCS project. I believe that the support by the city mayor was very important, decisive. The Tomakomai CCS site was located in an oil exploration area, and one of the leading shareholders of Japan CCS had acquired a lot of geological data. The abundance of existing geological data made it possible to decide the CCS site within a very limited period. Thank you.
Great, thank you. Another question we had come in with regards to the earthquake that was experienced a few years ago. One question: what were the probabilities that what were the probabilities that the earthquake fractures the underground reservoir and would release captured CO2, or that CO2 would move between layers as a result of fractures?
Okay, I will try to answer that one. I do not think we have figures about the probability of possible leakage due to the earthquake. However, we did do a calculation of the stress that would be caused by the earthquake at the injection site. And that stress was calculated to be less than the tidal forces of the earth. So, and this was again done as an exercise in the expert review meeting. And it was a strong indication that the earthquake could not affect the integrity of the CO2 storage. I hope that answers your question.
Yeah, great, thank you. Another question related to some additional storage locations. What areas are in consideration for future storage? What is being done differently to increase the willingness to accept a new storage site? And maybe talk a little bit as well about what is being done to characterize potential future storage locations, either onshore or offshore.
Okay, I'll answer that as well. So, as I mentioned during our presentation, we are conducting geologic surveys for potential sites offshore Japan. And so offshore has been regarded, given higher priority because mainly because of a public acceptance point of view. And so we have been conducting seismic surveys, 2D, and in some areas, some high-graded areas, 3D seismic surveys. The specific area where we have high-graded is confidential due to a number of reasons, but geologically, they tend to be on the Japan Sea side because tectonically, it's a more quiet area compared to the Pacific coast side. So, and to finally characterize these potential sites, we will do some exploratory drilling. But we are still at the seismic survey stage.
Okay, great. Thank you. Another question we had come in regarding injection, why was almost all of the CO2 injected into the Moebetsu Formation?
Thank you very much. Very good question. The Moebetsu Formation sandstone layer shows a very high injectivity. On the other hand, the Takinoe Formation volcanic rocks layer indicates very low injectivity as an injection well. According to our geologist, an exploration well drilled nearby found the formation to be composed of lava and tough breccia, and good injectivity was confirmed by water injection test. When the injection well was drilled, however, the reservoir around the well was found to be dense tufaceous rock, and the injectivity was confirmed to be very low by water injection test and subsequent CO2 injection test. The spatial and lithological variation of volcanic and volcanic classic rocks is in general very large, and we learned that it was very difficult to predict the characteristic because they are so heterogeneous. Thank you.
Great, thank you. One question we had with regards to other capture technologies. Are there any plans to use other CO2 capture technologies, for example, oxy-combustion or perhaps CLC-based CO2 technologies?
In case of Tomakomai, we just use a chemical absorption technique. But Kawi-san has shown 3 other locations, and one of them are physical. They use a physical solvent, something like that, and the other is chemical solvent, and the other is same with Tomakomai, just amine solution.
Okay, great.
Did I answer to your question? Yeah.
Yeah, thank you. Yeah, perhaps a question for Mr. Kawaguchi. What plans does METI have to facilitate the creation of a business environment and other incentives for CCUS in Japan?
Well, actually, it's a really good and tough question. Of course, it is clear that we need a legal framework such as long-term liability, and also the incentive such as like a 45Q in the US. But of course, actually there are another technology which can be introduced by 2030 or 2050, and also we need a lot to do, and there are also priority area. For example, we need of course a hydrogen facility, and also the facility for the electric vehicle and other innovative technology. So of course we need to do everything, but actually we are now discussing also, or still under discussion, what we need to introduce CCS as well. So actually, simply put, we are still studying. But as I have shown in the schedule, to introduce by 2030 at the commercial scale, the CCS, we don't have much time. So that actually we need to hurry up, and we continue to study what we need, like a legal framework as well as incentive. This is the answer to your question.
Yeah, thank you. I think related to that too, there's financing structures, legal frameworks, and financing might be a big part of that. How do you plan on financing some of the sounds like 80+ projects over the next 30 years that might be planned?
Well, actually, again, the financial plan really closely related to the legal framework. Again, in Japan, we still don't have any, for example, legal framework on the long-term liability. That means the private companies cannot assess the risks of the CCS. So without making such kind of legal framework, private company as well as financial company cannot decide what kind of and what scale of the financial scheme is needed. So again, legal framework and incentive or financial scheme relates closely. So we need to go forward on both sides.
Great, thank you. You know, one of the things Brian mentioned at the start was just being able to find ways to accelerate this technology broadly and globally. We have a question sort of related to that. Did your cost analysis or any broader analysis find any source of major differences with projects in other countries? And maybe were there lessons learned in either direction as you developed the Tomakomai project?
Okay, that's a good question. In case of Tomakomai, we have emittance source and capture facilities and injection facilities and reservoir. Almost all the facilities are the same places. So in case of Tomakomai, we do not have any transportation. Injection well is very adjusted to the capture facilities. And in case of Tomakomai, we have drilled well from onshore to offshore subsurface. So I think only Tomakomai drilled from onshore to offshore underground. So we did not mobilize extensive offshore drilling rig, so we could save the drilling cost. Thank you.
Great, thank you. I think we have time for one or two more questions. We had a few related to negative emissions in BECCS or BECCS. I guess broadly, what are the needs for and prospects for BECCS and negative emissions in Japan?
Well, I think, well, as I have explained in the graph, it shows the implication 80% reduction of Japan. And it says that, for example, there is 300 million tons of CO2 from industrial processes. So again, we need not only CCS, but also negative emission, as you said. And also actually, and I also explained that there is a, how to say that, the capturing demonstration, CO2 capturing demonstration project in the southern part of Japan. And actually, this is, again, this is southern part, and Tomakomai is northern part. And in this capturing demonstration project site, we don't have an injection well. We don't have an injection well. So that if we really want to realize the BECCS from this southern, the demonstration project in the southern part of Japan, and we need CO2 ships towards Tomakomai. And also, okay, so that is one possibility. But again, to do that, we still need to conduct a study and survey of CO2 ships. So hopefully we can do a demonstration project again. And again, this kind of a CO2 ship is needed. So of course, not only CCS, but to realize the BECCS, BCCS, we need that kind of a transportation program.
Great, thank you for that. I believe in the interest of time, we will have to move on from the Q&A session. So thank you again to the panelists for that informative session. For the audience, for any questions we didn't have time to get to, we will connect with you offline after the webinar. To wrap up, if you want to learn more about the CCUS initiative, including our next webinar offerings, please reach out to the initiative coordinator at the email displayed on this slide or visit the links provided here. For other news and developments, follow us on LinkedIn by following the link displayed here and on Twitter at CCUSCEM. Another kind reminder that these slides will be provided at the Clean Energy Solutions Center website following the conclusion of the webinar at cleanenergysolutions.org. One more time, I'd like to extend a thank you to our panelists and to our attendees for participating in today's webinar. We very much appreciate your time and hope in return that there were some valuable insights that you can take back to your ministries, departments, or organizations. Please enjoy the rest of your day, and we hope to see you again at future CCUS events. This concludes our webinar.